All right, here we go. So let's look at number 1. A half, 11/16, 3/8. Please give them to me in order, smallest to biggest, Jenna.
So I don't know if this is right.
Just give it to me.
6/8, 8/16, 11/16.
I like what you did. I'm going to write the original fractions down, and then I'm going to do what you did, because I love what you did. So the original fractions are 1/2, 11/16, and 3/8.
Yeah.
What did you do, Jenna? I'm actually going to ask you to answer number 4 for me. What did you do?
So what I did was, since 11/16 is already, 11/16 into an 8, if you multiply and come 16, so it's multiplying. Yeah.
Give me 2 words. What did Jenna find? A common denominator. So what she did was she called 1/2. She did this. This is cool. She multiplied both the top and the bottom by 8.
Yeah.
Now I want you to think about this move. What is 8/8 equal to? 1. If you multiply something by 1, do you change its value or does it stay the same? It stays the same. That means 1/2 and 8/16 are the same fraction. You ready for this? Hang on. Some of you are not buying this, and that's okay. I'm going to show you why. Hang on. Don't unlock me. You do unlock. I don't know why it locked me out in the first place. Okay, here we go. Ready for this, people? I'm going to go to your website. Just so you know, that little bit of the 8/8 that I just did is in the document we created on the first day. So if you go to your Math 58 course information right here online, if you go right here, this is the document that we created about methods 1, 2, and whatever. Here is a document we used last week, which is comparing fractions and seeing which ones are equivalent. So, the one we just did was 1/2. Here's what 1/2 looks like. Okay? Here's what 8/16 looks. Whoops. Hit the wrong buttons. My apologies. Control-Shift-F. 1/2, 8/16. 1/2, 8/16. 1/2. I'll stop talking now.
Thank you.
Thank you. So do you see what finding a common denominator actually does? 1/2 and 11/16 might be hard to compare, but if you put them both over 16s, they're just cats. One is 8 cats, and one is 11 cats. If that makes sense. If you're calling 16 cats now. Remember we talked about this earlier, right? The 20ths were throwing you for a loop. So I said, call them something else. Call them cats. The problem with this, right now, is you got cats, dogs, and ferrets. Right? You got 3 different denominators. You can't compare the 3 things because you ever heard the phrase apples, oranges? You're trying to compare 2 things that can't be compared because they're too different. Well, let's make them apples, apples. Common denominators are that way to make them apples, apples. So, for example, 1/2 is 8/16. That's the same fraction as we just saw here. 11/16, as Jenna correctly said, is already out of 16. How about 3/8? How many 16ths is 3/8? Let's take a look at 3/8. 3/8. That's what she looks like. The blue ones, that's the pieces I ate. Chloe, I ate those 3. 3/8 I ate. If I cut the pizza into 16 pieces, how many pieces would I have to eat if they were 16ths in order to be 3/8?
6.
I have a vote for 6. How do we feel about this? How do we feel about this? It's okay?
Yeah.
Okay.
That's where I came up.
That's good. So in other words, now they're all out of, if this is 8 cats, and that's 11 cats, and this is 6 cats, what's the smallest one?
6.
6 out of 16. So the smallest is 3/8. The middle one, in more ways than one, is what?
Half.
So you got it to half. And the biggest is what?
11/16.
11/16. There you go.
Oh, I did that wrong.
It's okay. Now, some of you, that's okay. Well, this is the order. Smallest, middle, biggest.
Well, no, see, I get that, but I did, for smallest to largest, I did the order, the smallest to biggest with the 16ths, not the original.
Well, still, it does. Oh, I see what you're saying, Jenna. That's fine. So you wrote 6/16, 8/16, 11/16.
Yes!
It's all good. It's all good. Now, some of you, as Jenna was describing that, were like, what the hell is she talking about? So it sounds like some of you may have done it differently. Can I hear another method if you didn't do it that way? Ellie!
The smaller number on the bottom means bigger portion unless it's like 9 out of 10.
Huh?
Okay, I see what Ellie's saying. It's a little bit trickier than with the way you did it, Jen. I'm going to go through this now. So Ellie said the smaller number on the bottom means the bigger portion. That is true. And I'm going to draw a picture to show you why that's true. So if we talk about halves, that means you've taken up. So all of a fraction, really, at the end of the day, is taking a circle and breaking it up into equal pieces. That's what a fraction is at the end of the day. So if you are breaking something into 2 pieces, it looks like that. If you are breaking something into 8 pieces, it looks like this. And if you are breaking something into 16 pieces, it looks like this, if I can draw it correctly. It gets hard to draw more than that, so please don't ask me to draw like 30 seconds or anything like that. It gets ridiculous. So what Ellie just said correctly is, the smaller the denominator, the bigger the portion. The only problem with that hopefully makes sense. That's the definition of what a fraction is. I mean, have you ever had a discussion where you have to split resources with someone and you realize pretty quickly, if we just don't give that person any, I get more?
Yeah.
It sounds selfish, but this is how Congress works. Oh, sorry, is that out loud? But literally, if you have a bunch of money and you have to split it with people, rivers work that way, right? I want to fish this river, my buddy's here. Damn, I get half. Same idea. But the trick is, that is only looking at the denominator part, right, L? So we gotta look at the numerator too, because technically, 16th is the smallest breakup, but 11/16 is the largest overall fraction. So there's 2 things you have to concern yourself with there. That's why you said your second part was good when you said, but here's this and yes.
Yeah.
Please.
So we looked at them, and in theory, 3/8 is less than half of a ferret, which is less than half of a cat. So that automatically bumps 3/8 to the beginning, and then there's half, and 11 is more than half of 16, so that makes it the biggest one.
And this is another great way of looking at fractions. You can compare them all to a half. You can look, a half is a special fraction. It's a very special, I think it's one we have a very intuitive kind of feeling with. Hell, Bon Jovi. Oh, oh, we're halfway there. Oh, oh, we're, oh my God, don't have to leave me hanging. Take my hand. Thank you. You have an intuitive notion of this number half, yes? Thank you, don't leave me hanging. So the thing is, if you could stick the half in the middle, now, we start by putting it in the middle, and then compare the other ones to it, we realize that 3/8 has to be smaller than a half because we're not completely there, and 11/16 has to be more because we're past it. I love that very much. It's also very, it requires a certain level of familiarity with fractions, which is why I kind of like Jenna's method too. That way you got a choice. You can pick either one. Anybody do it a different way? Please, Connor.
I just turned the fractions into their decimal equivalents.
And this is fine. I'm not going to ignore you, sir. Connor turned them into their decimal equivalents. I'm going to punt that. Don't change it. Do you know why I'm going to punt it? Does anybody know why I'm not going to have Connor explain that yet?
Because we're not there.
Technically, this class is supposed to teach that skill.
Okay.
Now, part of what makes Math 58 interesting is a lot of you have some of these skills from previous classes, and you end up at 50, and that's totally fine. So I'm not going to talk about that right now. We're going to talk about it soon, I promise. And then we can use decimals, whatever the hell we want to. Whatever. I just want to punt it right now. But I love the fact that you're doing that. That's a wonderful way. It's actually a very idiot-proof way of never screwing anything up. Enter, enter, enter with the biggest number. We'll get to that, I promise. Thank you, sir. Okay? Anybody else do it a different way? Or did you do one of those ways? It sounds like those are pretty popular and common ways of kind of doing these. Okay. Tommy used to work on the drum. Oh, it's in my head now. Let me look at that break. The key, how many musicians we got in this room? The key change in that song. A step and a half key change of a song that's already being sung in a high register. John Bon Jovi is gorgeous. He's also a total badass for pulling those notes out. I'm not gonna lie. Richard Sambora doesn't look so good anymore. John still looks great. Clean living, baby. Clean living. I tell you. All right, number 2. A third and a half, 9/10.
This is where I got stuck.
That's okay. Third and a half, 9/10. Ellie.
So, well, you put them in the right order.
Oh.
Yeah.
Apparently, that's the order. A third and a half, 9/10.
Yeah.
Okay, prove it to me.
Well, as I said earlier, half is the smallest number, but 1/3 smaller because it's bigger. But 9.
I'm gonna pause you right there for a second. Just I'm gonna come back to you in a second. First, let's look at a third and a half. Let's start with that. And the reason we're gonna start with that is because a third and a half both have a numerator of 1. That's nice, isn't it?
Yep.
That means they both have one piece of the pie. 1 is 1 out of 2, and 1 is 1 out of 3. Based on our previous discussion, the 1 out of 3 has to be smaller than the 1 out of 2 because the whole is being cut into more pieces, which means the pieces have to be smaller. So 1/3 definitely is less than a half. Anybody know by how much? This is a fun question. It's okay, we'll come back to that. We'll come back to that. We'll come back to that. Okay, how about the 9/10? Because 10 technically is the smallest denominator. It's the biggest denominator, which means it should be the smallest piece.
But even though it's like 10 pieces, but out of the 10 pieces, 9 are shaded.
But even though we've broken up, so it sounds to me like what some of you are doing, which I love by the way, is you're starting with the fractions by looking at the denominator and then going to the top and seeing how many of them we've got. That's what it sounds like to me. So it sounds like, so we've already got the half here. Out of 3 would look like this, right? Kind of like a peace sign. Mm-hmm. And the 10th is kind of hard for me. I'm going to try it though. I'm going to try 10. No, I'm going to cheat.
I only do 2/5.
No, I'm going to cheat because the 5th is hard too.
Oh.
I'm going to do this. There's 10. There's 10. There, I cheated. So definitely, a half is bigger than a third is bigger than a 10th. But the problem is we have 9 of those 10ths. Wait, hit the wrong button again, sorry. We have 9 of the 10ths, which means we almost have all of them. That's pretty close to a whole. So 9/10 is definitely bigger than 1 of the halves or 1 of the thirds. So it looks like, for number 2, it's 1/3, 1/2, 9/10, yes?
Yeah.
Anybody find a common denominator on this one?
30.
Yes! 30 is going to be your easiest common denominator. Anybody use 60? 60 will work too. I mean, the math gets bigger, but
You just have to reduce.
you do, or you don't have to either. You could use 60, you could use 90, you could use 120. There's a whole bunch of numbers you could use to get a denominator to be the same. 30 is the kindest one.
Figure out common denominators there.
I want to give you a hint. In case you want to go the common denominator route, forget least common denominator. You ever want to find a common denominator? Multiply all the denominators together. 3 times 2 is,
6.
times 10 is
6.
60. That's a common denominator. Not the smallest, but it's a common denominator and it'll work. Ready for this? Let's go, people. Let's do it out of 60. I'm not going to draw this. I hope you don't mind. I'm not going to draw 60. Yeah, thank you. Thank you, Jeff. Appreciate that. Okay. Pick one of them and write it out of 60 for me. One of the original fractions and write it with a denominator of 60. Pick the easy one first. Get off the hook. 30 out of 60. How did you know that? Ariel, how'd you know that? Because 30 is half of 60. Thank you. 20/60th, Nika, is a third, yes? Because 20 is a third of 60. Thank you. 9/10 might be a little bit trickier. What's 9/10 as a fraction out of 60?
54.
Oh, is that you, Amelia?
No, it was my ghost.
That was your ghost. Well, hi, Amelia's ghost. What should we call her?
Amelia 2.0.
Amelia 2.0. I like this Amelia tag team going on over here. 54/60th. Now, for those of you that are like, how the hell are we getting these numbers? You're using method 1. This is not new. This is week 1 stuff. This is method 1. For example, you're trying to go from 9/10 to something out of 60. So to go from 10 to 60, you're multiplying by 6. To go from 9 to whatever, you multiply by 6 to get 54. It's not magic. We're using method 1. Thank you, me and your ghost. It's quite nice.
I like his writing.
So now it's cats.
Or 9 times 60 divided by 10.
Yes, method 2. That works too, doesn't it? That's 540 divided by 10 is 54. I love it. Either way, that's again why I don't make you do it my way. Do it the way that makes sense to you. Yes. Okay, good. And now it's all in terms of cats. 20 cats, 30 cats, 54 cats. They're in order. Buying it? Thank you. Last one. I'm gonna turn the camera. Jessica, come over here. And Larry too's on this one too. He wanted me to record this for him as well. There we go. Sideboard over there, yes. All right. We got a 5th, a 6th, and 9/4. Best eraser ever. 5th, 6th, 9/4. Give me the order first. Jenna.
Okay, I wasn't gonna do the order, but
Okay, go ahead.
120.
So you're going to do common denominators. You want to go with the common denominator? Multiply all denominators together. 5 times 6 is 30 times 4 is 120. There's your common denominator. So these are all going to be out of 120. It's not the least common denominator. I think that would be 60. But it's definitely a common denominator. It'll always work for you. Okay, you ready? 1/5 is how many 1/20ths? Well, we don't have to do this stuff in our head. We can do this with writing, yes? 1/5 is how many 1/20ths? What do you have to multiply by? Oops, almost said it. What do you have to multiply by to get from 5 to 120? Use your calculators. I don't expect you to know this in your head. Jordan says 24. Who believes him?
Me.
Why do you believe him? Because you don't know. How can we figure it out? Yes, but what can you I love Matthias. What can you calculate? You know, ready for a little teeny bit of algebra? Can we do a little teeny bit of algebra? And I mean like this much. I mean this much, people. You've already done more than this in this class, believe it or not. Method 2 that was quoted earlier is more algebra than we're about to do.
120 divided by 5 is 20.
Yes, Amelia and Amelia's ghost. You're trying to figure out what number times 5 is 120. So in other words, 5 times something equals 120, yes? So you can figure out what the something is by dividing by 5. If you divide both of these by 5, you end up getting what you're looking for, and now you're going to put in your calculator is 120 divided by 5, which is 24, exactly. So it's 24 1/20ths. You see what you did? It's a little teeny tiny bit of algebra. How about 1/6? 20. Same exact math, except it's 6 times question mark is 120. How about 9/4?
270.
This is an interesting one, isn't it? This is a fun one. Let's play with this one. If we have 9/4, I love your answer, by the way, Jenna. Thank you. If you have 9/4, we can actually do this one without our calculators, I bet.
No.
4 times what equals 120?
30.
4 times what equals 12? 3. So 4 times what equals 120? 30. Get it? Think like a European. Adding a 0 just adds a 0. I can't believe I just said that. That makes no sense. Well, it makes sense. It's also useless. 4 times 30 is 120, which means no algebra needed. What's 9 times 30?
270.
It's 270. Which one has the most cats?
270.
That's the biggest. That's the smallest, that's the one in the middle.
That's a lot.
Now, there's also a really, really quick and easy, oh, sorry, go ahead. There's a really, really quick and easy way to do this one without doing any conversion math. Even easier than decimals, I think. Personally, I think it's even easier than decimals. Talk to me, which one has to be the biggest?
9/4
Why?
is crazy because it should be 2 1/4.
Well, then write it as 2 1/4. That's totally fine. You can rewrite that as 2 1/4.
It has whole numbers.
I got no problem with you calling this 2 1/4. I'm totally fine with that.
It has whole numbers, that makes it the biggest.
Well, there you go. It's more than one, so that has to be the biggest. The other ones are not more than one. Excellent. Which one has to be the smallest?
1/6.
Why? Because there are 6 pieces rather than 5, which makes the 6ths smaller than the 5ths. Yes. And you wrote something down for the question 4, correct? I just asked you to kind of explain your thinking, which we've been kind of doing this entire warm-up, so. Good stuff. Bring them in. Let's take 5, yes? I think everybody needs a break at this point.
If we did it like decimal form,
Totally fine. If you did it decimal form, that's totally fine. I'm just not talking about it yet because I don't want to get into something where I don't want to assume we ought to do that right now.
well, I did it decimal form the second time. I just used my calculator the second
It's
time.
all good. Am I speaking to Amelia or her ghost right now?
Both.
Both. Okay. It's very good. Both of you.
We'll throw it in Falele.
I love it. I love it, Amelia. It's totally fine. I'm never going to make you not use a solution method.
Okay.
It's just that I don't want to make the assumption that we know that method right now if it's part of the curriculum of the course. But don't worry, soon, probably Thursday, that we tackle that part of the course after we get through this lab.
I have a question.
Yes.
So, how much algebra is in 105?
Very little. I mean, all the algebra you're going to learn in 58 and 98, we don't add any more to it in 105.
Okay.
You're going to learn it in these courses for 105. Is that fair?
Yep.
My job is not just to teach you a bunch of algebra and then look back later and go, remember when we learned this, let's use it now. It's, oh, we need algebra right now, let's learn it right now. Like we just did. I mean, literally. That's how we just kind of used it. While you're taking your break, I'm wandering around and giving you our next lab. I doubt we'll finish it today. I should probably turn the camera off. Jessica, sorry, I'm still talking. We'll start it back up in a sec.
This is